Hello my colleagues, and I hope everyone is well. So what I want to do is pick up here on chapter 5 and continue talking about interest rates. So let me say hello to everybody. Hope everybody's well, my colleagues. All right, I'm going to shrink this now. All right, so I want to talk now about annual percentage rates. We talked about effective rates, right? But annual percentage rates, banks tend to quote interest rates in terms of an annual percentage rate. And this indicates the amount of interest earned in 1 year without the effect of compounding, all right? And they say that here, right? So they're going to not tell you anything about compounding. So you see right here, that is the amount of interest earned without the effect of compounding. Or paid, for that matter, too, right? Or the interest paid, for that matter, right? Because it does not include the effect of compounding, the annual percentage quote is typically less than the actual amount of interest that you will earn or pay, okay? So to compute the actual amount that you will earn in 1 year, we have to convert the APR to an effective annual rate. Okay, so there's an equation I have up on the blackboard. Let me see if I can find that while we're here. And here it is. So here's the equation that takes you back and forth. This is right up on your blackboard under announcements. This will take you back and forth between APR and annual percentage rate and effective annual rate, depending on which way you want to travel, okay? So I just wanted you to see that, all right? So it's right up there. So for example, suppose Granite Bank advertises savings accounts with an interest rate of 6%, and the compounding is monthly. So that means you're going to get interest every month. It's going to get compounded every month, right? But they don't say anything about credited, okay? That's another issue, if it's credited. In this case, you will earn 0.5% every month, right? 6% divided by 12, this is the APR. So now right away we know we have monthly compounding. So an APR with monthly compounding is actually a way of quoting a monthly interest rate rather than an annual interest rate. And because the interest compounds, and this is an important concept, because the interest compounds each month, you will earn 1 plus, okay, and it's 1.005, right, 5% every month, right, to the 12th power, and you will earn $1.061678, right? So at the end of 1 year, for an effective annual rate, so this is the effective annual rate of 6.6178, and that's how you came up with that number. Now, why I can't understand why. Oh, there it is. Hold on. I think I'm in the way. Let me move myself out of the way. All right. So the 6.1678 that you earn on your deposit is higher than the quoted 6% APR due to compounding. In later months, you earn interest on the interest paid in early, and this is the important concept, right? You're going to earn interest on the interest you paid in earlier months. All right, so just for your information, I opened up Microsoft Excel here, and I used the function in Microsoft Excel called effect. You click on f of x and you'll see effect, okay? So you have 6%, 12 periods, and you get 6.1678 approximately, right? Just what you got here. And then if I just say, okay, there it is, right? And I should format that cell as a percentage. Let's format that cell. Let's see if I can get this right. So I say okay, and there you go. I should have added a couple more decimal points, but I didn't. And it rounded it off. All right. So anyway, that's how you would do that. It is important to remember that the APR does not reflect the true amount you will earn over 1 year. And again, this is important. And when you take a loan, it doesn't reflect the total amount you're going to pay over 1 year either, right? In your loan, interest to the bank. We cannot use the APR itself as a discount rate. How do I do that now? Let me just get this. This is a real difference that, well, and if anybody has any questions, they should get a hold of me. Instead, the APR with K compounding periods is a way of quoting the actual interest earned each compounding period. So, which is what we did over here, right? We took the, you see it right here? All right. So interest rates, and now this is equation 5.2. Interest rate per compounding period is APR divided by K periods per year. Once we have computed the interest earned per compounding period, we can compute the effective annual rate by compounding using the equation 5.1, right? Thus, the effective annual rate corresponding to an APR with K compounding periods per year is given by the following conversion formula. So here we are, and this is what I have on the blackboard. We're converting an APR to an effective annual rate, all right? By the way, this was equation 5.1, remember? Here I am using equation 5.1. So if I go back, well, I don't want to go back. And it says, once we have computed the interest earned, we use equation 5.1. Thus, the effective annual rate corresponding to an APR with K periods. And this is the other equation I have up on the blackboard, all right? Converting an APR to an EAR. And if we look at this table here, you can see the more compounding periods, the more you're going to earn. Okay? But again, there's a discrepancy that they don't talk about here, because the real question is, even if you get this, you don't know if that interest you're getting is being credited to your account, so it could continue to earn interest. Okay? So you may be getting a higher rate, but it all depends on when they credit that interest into your account. All right. So there's another term that's important and you should understand, and it's called continuous compounding, which we'll get to. And the continuous compounding is the compounding of interest every instant in time, an infinite number of times per year. Infinitesimally small periods times an infinitesimal number of times. So you can see here as the the interest rate goes up, the more compounding. Okay, so remember when working with APRs, these are the important rules. Divide the APR by the number of compounding periods per year. All right, and we did that. That was okay. To determine the actual interest rate per compounding period, that was equation 5.2. All right, compute the appropriate discount rate by compounding, and that was equation 5.1. All right, so we had to do equation 5.1. Once you have completed these steps, you can then use the discount rate to evaluate the present or future value of a set of cash flows. So that takes care of that. So here's the effective annual rate. Okay, so I'll stop here. We're about 10 minutes in, and I'll pick up on this nice example, which is a little complicated, in the next video, okay? So I'll pick up here. So I just want to say, as usual, if you have any, this is a tough chapter. If you have any questions, just, feel free to, email me, and we could discuss things, okay? Okay, so I'll wave goodbye and I'll say hello to everybody. So, so long, everybody. All right.